Let's take a look at the probability tables questions. So question number 1, for a pupil chosen at random, what is the probability it is a boy that prefers dogs? So first of all we need to think, well, how many pupils are there in total? Well, there are 7 plus 3, 10 plus 4 plus 6, 10, so in total there are 20. So out of the 20, how many are boys that prefer dogs? Well, that is 7 out of 20. What is the probability that it's a girl that prefers dogs? Well, that is 3 out of 20. And we've got to be careful with C. So we're choosing from the girls. Now, in total, there are 9 girls. So of the 9, how many of these 9 prefer cats? Well, that is 6 out of 9. And that can be simplified to 2/3. Given that a chosen pupil prefers cats, so how many prefer cats? That is 10 that prefer cats. And of the 10, how many are girls? That's 6 out of 10, which is the same as 3 out of 5. Question number 2, 2 fair die are thrown at the same time and the results are multiplied. So first of all, we're going to populate this probability table here. So 1 times 1 is 1, 2 ones are 2, 3 ones are 3. So this is just the 1 times table. 1 2's 2, 2 2's are 4, so this is the 2 times table. 2 4 6 8 10 12. This is the 3 times table. 3 6 9 12 15 18. This is the 4 times table. 4 8 12 16 20 24 5 10 15 20 25 30 6 12 18 24 30 36. Done. What is the probability that the result is a square number? So the square numbers, 1 times 1, which is 1, 2 2's, which are 4, 3 3's, which are 9, 4 4's, which are 16, 5 5's, which are 25, and 6 6's, which are 36. So we can clearly see that down this diagonal here, we've got the square numbers because that's 1 times 1, 2 times 2. But we've got to be careful because that we do see 4 in other places here and here as well. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So that is a total of 8 out of 36. And that can be simplified to 2/9, but 8 out of 36 is fine. What is the probability that the result is greater than 11? So the ones that are greater than 11 are contained here, but less than 17. So less than 17 are these ones in here. So that's 1, 2, 3, 4, 5, 6, 7 out of the 36. And what's the probability of the result being odd? Well, let's just go around. You'd think it might well just be 50%, but there's no guarantee given that we're doing a lot of multiplying here. So how many odd numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is 9 out of 36, and that can be simplified to 1/4. Question number 3, we need to populate the table by adding the scores together. 1 plus 1 is 2, 2 plus 1 is 3, 4, 5, 6, 7, 2 plus 1 is 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11. So what's the probability of the total being 5? Well, we've got these 4 here. In total, there are 6 times 5. There are 30 numbers in total, or you can count them individually if you want. So that's going to be 4 out of 30, which can be simplified if you want to 2/15. For C, what's the probability of the total being greater than 7 but less than 10? Well, that is these 1, 2, 3, 4, 5, 6, 7 numbers here. So that's 7 out of 30. What's the probability of getting an even total? So the evens is the 2, the 4s, these 6s here, the 8s, and the 2 10s. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 out of 30, which is 1/2, which makes sense. And E, the probability that the spinner shows a number that is greater than the die. Right, well, what we're going to do here is on this diagonal, we know that the spinner and the die have the same number, 1, 1, 2, 2, 3, 3. So we need to just think, well, these are the numbers on this side where the spinners are 2, the dies are 1. So these are the numbers. I know the diagram's getting a bit messy here, but these are the numbers in this section here where the spinner number is greater than the die number. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 out of 30, and that can be simplified to 1/3. Question number 4. First of all, we're just going to populate by just adding the rows and adding the columns. So here, 40 plus 23, you can use a calculator if you want. That's 63, 31, 37, 57. The rows come to a total of 69, 119. And this number here should be both the 69 plus 119 and 63 plus 31 plus 37 plus 57. If that's not the same number, then there's a mistake. So 188 is 69 plus 119, and I'll just double check that 63 plus 31 plus 37 plus 57 is 188, and it is. So for a passenger chosen at random, so out of the 188, what is the probability that they're vegetarian and in economy? So vegetarian and economy is 36. So that's 36 out of 188. You can simplify that, but I believe this answer is acceptable. For C, for a passenger chosen at random, so that's out of the 188, what's the probability that they do not have a standard meal? So we're not interested in the standard meal, but they are in business class. So not standard, but they are in business, so that's 10 plus 15 plus 21, and that is 46 out of 188. D, we're choosing from the kosher passengers, so that's out of the 37. What's the probability that they're in business? So that's 15 out of the 37. And for this last question, we're choosing from the economy passengers, so that is out of the total of 119. The probability that they're having a halal meal is 21 out of 19. So for question 5, the first thing we need to do is to populate this table. So what we're looking for is either a row or a column that only has one missing value. So for example, in this total column, we've got only one missing value here, so we know the grand total is 310. Of the 310, 173 are married, so the rest are not married. So that calculation is 310 take away 173, which means that in total 137 were not married. We can also work out the number of 18 to 29s that were married. There's two ways we can do it. We can either subtract these three values from 173, but even easier, we can just subtract 56 from 94. We know that in total there are 94 people between 18 to 29, so if 56 are married, if 56 are not married, then the rest are married. So 94 take away 56, that is 38. Okay, now we can also work out the number that are in the 50 to 64 age group that were not married. That is 55 minus 23, and 55 minus 23 is 32. And with this piece of information, I can now work out the not married in the 30 to 49 age group. So we know there's 137 in total, so if we subtract the 65 pluses, the 50 to 64s and the 18 to 29s, we've got the remaining group, the 30 to 49s. So 137 minus 19 minus 32 minus 56, or alternatively add these three values up and then subtract that total from 137. We know that there are 30 to 49s. Now we can work out the total 30 to 49s, which is 45 plus 30, which is 75. And we can also work out the 65 pluses. In fact, we could have done that right at the start. 67 plus 19 comes to 86. Now, when I put in my final value as a test, I'm going to add these four values up just to check that they add up to 310. And if they do, I'm relatively confident that everything else is accurate. And it does add up to 310. So we've populated the table. We've done part A. Part B, for a respondent chosen at random, what is the probability that they are married? Well, how many people are there in total? Well, there's 310. And of the 310, how many are married? Well, there's a total of 173 married. So 173 out of 310. Done. For a respondent chosen at random, what is the probability that they are under the age of 50? So of the 310, which is the total, how many under 50s are there? Okay, under the age of 50, that is the 75 that are 30 to 49, but also the 94 that are between 18 to 29. So 94 plus 75 is 169. So that is a total of 169 over 310. So it's worth checking if a fraction can be simplified, but this fraction cannot be simplified. So for part D, we need to be careful here because we've got this given that clause. So given that a respondent is 65 plus, so that means we're only looking in we're only interested in this column here. So out of the total 65 plus, so that is the total of 86. So out of these 86, what is the probability of not married? Well, not married is 19 out of that 86. So there's our probability, 19 out of 86, not out of 310. And for part E, another given that a respondent is married, so we're interested in the people that are married. So how many is that? That's 173. And of those 173, how many are not under 29? Well, not under 29 is the sum of these three values here. So that's 45 plus 23 plus 67. So that's 135 out of the 173. And that fraction can't be simplified. Okay, so assuming the data is representative of the total population, and given that there are approximately 54 million adults in the UK, estimate the number of married people in the 18 to 29 age category. Okay, so married in the 18 to 29 age category is 38 out of a total of 310. So what we need to do is work out 38 310ths of the population of the UK. So we're assuming that the UK has a similar proportion as this survey. So 54 million is helpful if we write this in figures. So that's 54 with 6 zeros. So what is 38 310ths of this figure? So here we're working out a fraction of a total. So what we do is we take our total, which is 54 million, we divide it by the number on the bottom, and then we multiply by the number on the top. So 54 million, so 54 with 6 zeros, make sure you put in 6, not 5 or 7, divided by 310 times 38, and that gives us an answer of 6619354.839, and we want to round to the nearest 10,000. So let's have a look. What do we need to do now? So we've got units, tens, hundreds, this is the thousands, and this is the 10,000s column. So if we're rounding to the nearest 10,000 column, we need to look at the column to the right, which is the thousands column, and this is a 9, so this will round the 1 up to a 2, so that will become 6, 6, 2, and everything else will become a 0. So that's 1, 2, 3, 4, 0, 0, 0, and of course 0.000 isn't doing anything useful, so we can simply round our answer to this, and we can read that as 6,620,000.